Weather. Weather is the temporary condition of the atmosphere in a specific area. Climate is the average weather of an area over a long period of time. The atmosphere is all of the gases that surround Earth. It is made up of layers with different properties. The layer closest to the Earth is called the troposphere. Almost all weather happens in the troposphere, but occasionally weather can stretch into the stratosphere, the layer above the troposphere. Weather is made up of 6 parts: temperature, atmospheric pressure, wind, humidity, precipitation, and cloudiness. These parts combine to describe the weather in a location. Temperature. Temperature is a measure of how hot or cold an area is. We measure temperature using a thermometer. Gabriel Fahrenheit invented the first mercury thermometer in 1714. A mercury thermometer measures temperature using rising and falling mercury in a tube. Fahrenheit divided the space on his mercury thermometer between freezing and boiling water into 180 degrees. He set the freezing point at 32 degrees so that he didn't need to use negative numbers to measure the coldest ice water he could create in his lab. Outside, however, temperatures do reach negative numbers. The coldest temperature recorded on Earth was negative 128.6 degrees Fahrenheit on July 21, 1983, in Antarctica. While we still use the Fahrenheit system in the United States, the rest of the world uses Celsius to measure temperature. In 1742, Anders Celsius divided the space between freezing and boiling water into 100 degrees. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. The hottest temperature recorded on Earth was 56.7 degrees Celsius, or 134.1 degrees Fahrenheit, on July 10, 1912, in Death Valley, California. In the troposphere, the air gets colder as elevation increases, so the top of a mountain is colder than the valley below it. One of the reasons Death Valley is so hot is that it is 190 feet below sea level. Air temperature also changes based on latitude. Sunlight hits the equator more directly than the poles, so the air around the equator is warmer than the air at the poles. Atmospheric pressure. Atmospheric pressure is the weight of the atmosphere above us. Meteorologists measure atmospheric pressure in atmospheres, millibars, and inches of mercury. 1 atmosphere is equal to 1,013.25 millibars, or 29.9 inches of mercury. A barometer is a tool used to measure atmospheric pressure. It records measurements in millibars or inches of mercury. The atmospheric pressure is higher at lower elevations than higher elevations because more of the atmosphere is above the surface. At sea level, the atmospheric pressure is equal to 1 atmosphere. At the top of Mount Kilimanjaro in Tanzania, the atmospheric pressure is 0.4 atmospheres. Atmospheric pressure also changes depending on the temperature of the air. Warm air rises, so atmospheric pressure in warm areas is low because there are fewer air molecules near the surface of the Earth. Low pressure areas are usually warmer with storms and rain. Cold air falls, so atmospheric pressure in cold areas is high because there are more air molecules near the surface of the Earth. High pressure areas are usually cooler with clear skies. Wind. Wind is the movement of air. Air moves due to differences in pressure. Air molecules move from colder high-pressure areas to warmer low-pressure areas. When warm air rises, fewer air molecules are left near the surface of the Earth. Colder air molecules rush in to fill the space left behind by the rising warm air molecules. The higher the pressure difference between 2 areas, the faster the wind blows. There are both local and global winds. Local winds are the winds caused by geography of the area, including bodies of water and mountains. These winds move from areas of high pressure to areas of low pressure in relatively straight lines. Global winds are much larger and caused by the uneven heating of the Earth and the Earth's rotation. As warm air heated by the sun at the equator rises, cold air from the poles rushes in to fill its place. These winds do not move in a straight line. They curve based on the spin of the Earth. The equator spins faster than the poles, so as air from the North Pole moves south, it deflects to the left. As air from the South Pole moves north, it veers to the right. The way the speed of Earth's rotation changes the direction of moving wind and water is called the Coriolis effect. The fastest winds on Earth happen during tornadoes. In a tornado, air spins around a low-pressure center. In 1999, the strongest tornado winds ever recorded during the Bridge Creek Moore tornado near Oklahoma City. During the storm, meteorologists measured wind speeds of about 300 miles per hour. Hurricanes also have strong winds, but the highest wind speeds recorded during a hurricane were only 190 miles per hour. Humidity. Humidity is the measure of how much water vapor is in the air. Meteorologists usually report humidity as relative humidity, the percentage of the maximum amount of water vapor air can hold at a given temperature. For example, a relative humidity of 70% means that the atmosphere is holding 70% of the water it can hold at that temperature. If the relative humidity is 100%, the air is saturated and can't hold water vapor anymore. The extra water vapor condenses into liquid water and forms fog. Warm air can hold more water vapor than cool air. As warm air rises, it cools, and the amount of water vapor it can hold drops. When this happens, the water vapor condenses and clouds form. Air temperature also drops at night, and the amount of water vapor the air can hold decreases. This is why you may find dew on your lawn in the morning. Precipitation. Precipitation is water that falls from the sky. Depending on the air temperature, precipitation can be rain, hail, snow, or sleet. At high altitudes, where the air is colder, water vapor from the atmosphere condenses into liquid water and forms clouds. A particle of dust or smoke in the atmosphere acts as a condensation nuclei where water could condense into droplets. The water droplets gather together and form a cloud. As more water droplets join the cloud, it gets bigger. When the water droplets of the cloud get too heavy, they fall as precipitation. Most precipitation starts as snow at high altitudes, but becomes rain closer to the Earth's surface. Most precipitation happens in low-pressure areas where warm air rises. As the warm air rises, it cools, and water vapor condenses into liquid water and forms clouds. High-pressure areas have little precipitation because the falling air doesn't form clouds. The world's largest deserts, including the Sahara Desert and Antarctica, are both in high-pressure areas. Cloudiness. Cloudiness is the number of clouds in the sky in a given area. Meteorologists measure cloudiness in octas, or eighths of the sky. A measurement of 0 octas means there are no clouds in the sky, and a measurement of 8 octas means the sky is full of clouds with no breaks between them. Meteorologists classify clouds based on how they look. Stratus clouds are flat and may have layers. Cumulus clouds are puffy. Cirrus clouds are wispy, and nimbus clouds are full of rain. Meteorologists combine these names to fit different clouds. For example, a nimbostratus cloud is dark gray, full of rain, and covers the entire sky. There are over 100 combinations to name clouds. Their heights above the ground also classify clouds. High-level clouds form above 20,000 feet. Middle-level clouds form between 6,500 and 20,000 feet, and low-level clouds form below 6,500 feet. Clouds are an important part of weather because they lead to precipitation, such as rain and snow. They also affect air temperature. When clouds cover the sky, they block sunlight from reaching the Earth's surface. During the day, this makes the cloudy days colder. However, at night, clouds prevent heat from leaving the Earth, so cloudy nights are warmer than clear nights. Deserts have little cloud cover, so they are often blisteringly hot during the day and freezing at night. Monitoring weather. The weather is always changing. Meteorologists use a variety of tools to monitor the weather, including thermometers to measure temperature and barometers to measure atmospheric pressure. They also use weather balloons and weather satellites to monitor the weather. Starting in the late 1930s, meteorologists have sent weather balloons high into the atmosphere twice a day to gather information about the atmosphere and weather. Weather balloons carry instruments that measure the air's temperature, pressure, humidity, and wind speed, and they are still the most accurate tool meteorologists have for collecting weather data. On April 1, 1960, NASA sent the first weather satellite into space. The first weather satellite was basically a camera in space that captured weather from above the clouds. Today's weather satellites have sensors that can track infrared, visible, and microwave radiation to create a more accurate picture of the weather on Earth. Weather satellites are either geostationary, meaning they stay over the same part of the Earth all of the time, or they orbit Earth every 12 hours. Geostationary satellites help watch the weather in one location, and orbiting satellites track the weather as it moves. Watching the current weather helps meteorologists make predictions about future weather. These predictions can help people make decisions about what they wear and do. Meteorologists can also predict extreme weather, such as hurricanes and tornadoes. These predictions help keep people safe because it gives them time to protect themselves.